everyone, this is Presley of ActOutGames.com here with Pino Chichi, and today we're going to do What is an Atom, even though it's backwards on camera.
Well, it'll look right on the camera.
Yeah.
So I talked about in my vlog the other day about how I was wanting to show a little bit of the work that Presley and I do kind of for homeschooling and some of the things that she's learning, and her teaching a little bit probably will help her learn a little bit better. Mm-hmm. So one of the things we've been doing is chemistry, starting with the atom and how an atom works and what the components are in an atom. And so I figured that's we'd do a real quick overview of the atom and talk for just a second about the periodic table, which a lot of you guys have seen before, and just do a real quick explanation of why the periodic table looks the way that it does. What is it about the atoms that make it make sense in the periodic table? So an atom is kind of the smallest discrete piece of matter, right? There are things that make up an atom. Well, there are things that are smaller that make up an atom, but like gold or silver or helium or hydrogen, you can break them up into smaller things, but they lose their identity when you break them up into smaller things. Mm-hmm. So we're going to talk about like a piece of gold or silver or hydrogen. What does that mean? It's an atom, but what is inside that atom and what's it made out of? So, Presley, there are three things that an atom is made up of. What are those three things?
Protons, electrons, neutrons.
Protons, electrons, and neutrons. So we'll do protons, neutrons, and electrons. And where do the protons live?
They live in the
protons.
nucleus.
In the nucleus, right?
Which is just make a circle and put a proton in it.
So we'll make a little proton in here. And then protons, or why would I put a plus there?
Because protons have a positive charge.
They have a positive charge?
Yes.
And how do you remember that protons have a positive charge?
Okay. Positive proton, positive plus, positive proton and plus.
Yeah, positive, it starts with a P, and proton starts with a P, and plus starts with a P. So that's an easy way to remember it. And then...
And also you can remember pro is positive.
Yeah,
and
pro.
It's at the beginning of proton.
Pro is positive and proton. That's right. That's a good way to remember it too. And so if you took a bunch of protons and you put them in the nucleus all together and kind of crunched them all together, what would happen?
They would all pull apart because if you've played with magnets before, you know that one side that are the same side don't connect together because there is a positive side and a plus side.
Negative.
Negative side.
Yeah.
A positive and negative side. And positives repel from each other and negatives stick to each other. Negatives stick to positives.
Yeah.
Positives.
If they're the same, they push apart.
Yes.
And if they're different, they attract to each other.
So
if you put all these positives together,
they would explode.
They would push each other apart.
Yes.
Yep. So how do you keep that from happening in a nucleus? Why doesn't a nucleus do that?
Neutrons.
Neutrons, that's right. So
Just don't add anything. That's
protons.
don't add an.
And then you can put neutrons in there that help space out the protons so they don't blow each other apart, right? And then what's the charge on a neutron?
Nothing.
It doesn't have a charge, that's right. So it doesn't repel or attract to the protons. Okay? So
It's just there to add weight.
that takes care of the protons and the neutrons. That's right. It does add weight. That's right. So now you've just got a whole bunch of positive things floating around in here in the nucleus. How do you make it so that the overall atom is not positive? The electrons. And where do the electrons live?
All the way out here.
They live, out here in shells and orbitals, right?
Which we will be talking about later.
And what are the charge on an electron?
Minus.
It's minus. That's right.
Why isn't it a circle?
Why isn't what a circle?
This.
Well, I'm not drawing the shells yet. We'll do that here in a second. So, how many, if you have 5 protons, how many electrons do you have so that you don't have an electrical charge? 5. That's right. You have the same number. Typically in an element or an atom, you'll have the same number of electrons and protons so that you don't have a charge. And if you get extra electrons or you lose electrons and they don't have the same, then your overall thing will have a charge, and that's something that we'll talk about a lot more later. So what is it that makes an element an element? An element of gold, or an atom of gold, or an atom of aluminum, or an atom of helium? What is it that makes it that?
This and this number.
Which number?
Atomic.
Well, the atomic number is what?
Made up of these and it's made up of the
What's the important thing to count to tell whether something is gold or not? The protons, right? So the number of protons determine what it is. So if anything with one proton is hydrogen.
Yes.
No matter how many electrons it has, or how many neutrons it has, or no matter what else kind of changes that's weird about it, it's just the number of protons that matters, that tells what it is. And so, again, if we go back to the periodic table here, you'll see that these are in order, right? 1, 2, 3, 4, 5, 6.
The one we're talking about is right there.
And those numbers are the number of protons that are in that element. So that's how they get put in order on the periodic table first. But then you can ask about, why is it shaped that way, and how do you know how many rows and columns need to be there? And that's all about the electrons. So they're all in order of the number of protons they have, but the important thing about what rows and columns they are is about the electrons. So let's simplify this a little bit, and we'll just kind of make a little nucleus here. And in here, you can just pretend that this is all full of protons and neutrons.
And blah.
And whatever, yeah. And we're going to show how the electrons kind of fit around that. And electrons live in things called shells and orbitals, right? And so this is what we're going to draw here is a way to see how they fit, but it's not really what they look like in the real world. It'll take a few videos before we start talking a little bit about how they really look.
I know how they kind of.
They look very different where they actually live is different. But drawing the circles and making it look kind of like the planets around the sun or something is a good way to talk about it, right?
They live in a different. They live there.
And so you can think of it as there being like circles around the nucleus. And electrons live in those circles, but only certain numbers of electrons can live in each one of the circles, right? So let's talk about the first circle out from the nucleus. How many electrons can live there? I don't think they can see that.
2.
Can you say it?
2.
2. So 2 electrons can live there in that shell, and it's in an orbital. And what's that orbital called?
Orbital?
What's the letter of that orbital, the first one?
D?
Nope.
S?
S, the S orbital. So the S orbital lives here, and 2 electrons. So we can draw a little line here and say 1 electron can live here, and 1 electron can live here. And then when that is full, that level is full, that shell is full, and no more electrons can live there. So one of the things that you'll see is, or that we'll learn about a lot, is that when you're doing atoms, any atom that only has 1 electron in its outer shell is a certain kind of atom, and any atom that is full in its outer shell is a certain kind of atom, and any atom that only needs 1 is a certain kind of atom. So the number of electrons in the outer shell is really important, because a lot of times...
It's reactive because it only needs 1 and hasn't?
Yeah, it only has 1 and only needs 1, so it's super reactive. So a lot of times if an atom only has 1 electron in its outer shell, then it's always looking for another atom that only needs 1 in its outer shell so that they can be complete. You can think of them as always wanting their outer shells to be complete. And so, if you find something that just needs 1 versus something that just has 1, then they join together really well. So if you look, number 1 has only 1 in its outer shell. Number 2 has a complete outer shell. And you can assume that these have the same number of protons. So this would be the element that's the second. And then when we go to the next shell, how many electrons can live in that next shell?
8.
8. So there's another S orbital that has 2. So that's not really critical to know. But what you'll see here is that the third one, when you get to the third one, you've got another outer ring that only has 1 in it, right? And then let's draw the rest of these. 1, 2, 3, 4, 5, 6, 7, 8. And then that's full. Okay, so you have the inner shell holds 2. The next shell holds 8. And so when you have 2 here and 8 here, you've got 10, and it's full. And the 11th one becomes on the next shell and becomes all by itself out there. So the ones that we've talked about so far that are all by themselves are 1. So the first one just has 1 all by itself. And then the third one is in the second shell all by itself. And then that fills up. and then the 11th one is in the third shell all by itself. And so now if we go back to the periodic table and you look at the far right hand column, you'll see that those are 1, 3, and 11, the ones that we just talked about. So the ones that just have one electron in their outer shell. The other thing, if you want to look at the ones that are full in their outer shell, so that's 2, because the second when you get to 2, that fills up the first shell. And then how many does it take to fill up the second shell?
16.
No, second shell.
Second? 8.
8. So there's 8 in the second shell plus the 2 that were in the first shell, so that's 10, right? So you have 2 and 10 are full, and on here, if you look on the ones that are completely on the other side, helium and neon, that's 2 and 10. So you start to see that the colored columns that exist here in the periodic table all map to how many electrons are in the outer shell. And you'll see that you can see a column of atoms that have one electron in their outer shell and a column of electrons that need one in their outer shell, and they react really strongly with each other. And so that's how things got on the periodic table. Or actually the way the periodic table was made is because people could see how atoms would react with each other, and they didn't really understand why they reacted in certain ways and why they reacted together. But now we understand it's because of the electron configuration in the outermost shell, or the valence shell. And so we understand why they put them in that order, and it was just brilliance on their part that they were able to build the periodic table without knowing how the electrons worked. But so when you start going through this, you can learn, there's a pretty easy way to draw a diagram, maybe we'll do that in another video, that shows you where electrons go in the shells and orbitals. And so you could just say, like for example, Presley the other day, when I left for work one morning, I said, hey, I want you to draw the atom that has 35 protons. And so she was able to draw, she put the nucleus, and then she knew that there were 35 electrons, and based on the rules, she was able to know where to put the electrons in the various shells and orbitals, and then she knew which column it should be in the periodic table, because she knew how many electrons were in the outermost shell after she had drawn it all out, right? And so that explains why the periodic table looks the way that it does and how it fits together. And you can understand how the columns work there. And then we'll probably talk a little bit later about what the significance is, other than how they react to each other. Yes?
I have something to also say.
Okay. Camera, please.
Okay, I have my periodic. So, if you're having trouble navigating the periodic table, even after what we told you, well, you can do it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12, and then you can just count as it goes down the rows, because 1 and 2 are on the same row, and then 10 and 3 are on the same row, and 87 and 119 are on the same row. So you just go counting, and if you want, and then we haven't really, I haven't really been explained to what this is.
Yeah, we're getting there. Yeah, we'll do that one a little bit later.
These are.
But it's exactly the same thing. It's because of the way their electrons are in the outer shell. And then, here, hold this for just a second. So one of the reasons that there's these big jumps between is because you go from hydrogen over here, which just has one electron in its outer shell, and it needs more. When you get the second one, that one's full, so it has to jump all the way over here to this side, where you have the ones that are full in their outer shell, because it only holds 2. And then the next one, to go from only 1 to full, is longer, so you have to fill up more. And when you get to the next shell, it's even more, so you start to see that it gets even longer to be able to fill up the shells. So it all fits together, and as we talk through it more, I think it'll make a lot more sense. Anything else interesting that you want to mention about the atom and how it's structured in the periodic table?
Not really. I'm just glad that I could get my thing out there, that if you're still having trouble navigating the periodic table, you can also think of it. Yeah, you can also count, and you'll find your way.
Yeah, they go in numerical order across. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and that's just the number of protons that exist in them, and it just keeps going. But the reason that it's shaped kind of funny the way that it is because of the way the electrons go together, right? And maybe in another video we'll do, or your channel or my channel, we'll do one
Or on both of
where
us.
we draw a couple of elements, you know, based on the number of electrons there, and we'll show the tricks for making the electrons work. Cool? Okay, anything else? Okay, you want to sign off?
Bye.
Bye.
They had a cable died.